Welcome to the fourth part of fourth module, that is optimizing infrastructure deployment with Packer. So in this, we are going to discuss about the Packer, what is Packer, and how the Packer helps us in dealing with deployment very easily. So Packer is an open source DevOps tool made by the HashiCorp to create identical machine images for multiple platforms from a JSON config file. So that's what they initially used one. Now they have HCL, that is HashiCorp configuration file. So either of language you can use, either JSON or H, HCL. So this tool really, when it comes to creating immutable architecture, so you can use Packer for AWS, GCP, and Azure. So we are going to look into all these details about a Packer. So we are going to begin with just we're going to begin with what benefits it brings to us and what is Packer. Then we will look into some of the use cases of Packer. Then we will look into Packer terminology, and we'll begin with JSON language, and then we'll see a lot of commands that are related to Packer CLI. Then we will also go to the HCL, and then we will do some example using Docker, some example using Linux machine, and then we will convert a JSON config file into the Linux config file. So this is what we are going to touch upon in this part of fourth module. So in previous modules, we have learned how to provision a cloud infrastructure using Terraform, and then we continued with the automated configuration of provisioned virtual machines with virtual machines or instances with Ansible. Now here, this automation allows us to benefit from a real improvement in productivity and very visible time saving. So however, despite the automation, we notice the some of the following pain points with the existing tools. The first one, configuring a virtual machine or an instance or a server can be very time consuming because it depends on its hardening as well as the middleware that will be installed and configured on that instance or virtual machine. So between each environment or application, the middleware versions are not identical because their automation script is not necessarily identical or maintained over time. Hence, so for example, the production environment being more critical will be more likely to have the latest version of packages, which is not the case in an production environment. So and with this situation, we often encounter issues with the behavior of applications in production. I will give you the live example. So what's happening, so we have been working on one AI application. So it is called fleet management solution. I do not know so whether I can tell this or not, but that's okay. I'm just giving the broad details about that. It's not the complete detail information about that, so I'll just give you the brief details about that. So It's a fleet management solution. It's based on computer vision. So we have been working on that project for last 2 years. So I have taken this project. Now I'm the project lead for this one. So this is a bloody fantastic computer vision based project. So what we want to test that application, but what we thought is now it is in basically developer environment. So we did not put it into neither quality or QA environment or testing environment or staging environment or production environment. So in developer environment, most of the packages that we have used, most of the tools that we have used are not the upgraded or updated one. So because of that, when we were testing this application inside the site, we have faced a lot of issues. We used to face a lot of downtime of the server. So this is the best example I have basically seen in my life. So that's what I'm talking about here. So when when it comes to the production environment, we'll put all the upgraded tools and upgraded packages, where when it comes to the stages where which is lesser than the production, such as staging or maybe a developer server. So what will we do is development server, what will we do is we'll use the downgraded services and downgraded tools and downgraded packages. Because of that, we're going to face a lot of issues. So configuration and security compliance is not often applied or uploaded. To address these issues, all cloud providers have integrated a service that allows them to create or generate custom virtual machine images. So these images contain all of the information and all of the configurations of the VMs with their security, administration, and middleware configurations, and can then be used as a basis to create VMs for applications. So the benefits of using these images are: one, the provisioning of a VM or an instance from an image is damn fast. It's very quick, fast. Then each VM or instance is uniform in configuration and above all is safety compliant. So among the infrastructure code IAC tools, among all of these benefits, IAC infrastructure as code tools, there is Packer from the HashiCorp tools, which allows us to create VM images from a file or a template. So it's like a template. You create one template and you put it everywhere. You apply it to everywhere. It's like for example, in Volvo, we have a Volvo group templates for presentations, around 25 templates. So at any cost, in one PPT we have 25 slide templates. So whatever PPT you want to create, you have to just replace the images in that and replace the text in that, replace the heading and headlines in that. So that's it, nothing much to do. So like that, here also there we can use one template that can fit for all the services, all the cloud services, all the places, irrespective of what operating system it is, irrespective of which cloud provider it is. So that is the biggest benefit of Packer. Now it's time to see what is Packer. So Packer is an open source for creating identical machine images. I stress upon this: identical machine images. What does it mean? What does identical machine image means? So what happens if you want to run a server? I'm not just talking about an OS, an operating system. For example, if you want to deploy an HTTPD service and then you want to run an application in that, so it consists of 3 to 4 layers of activities. So now for to do that, in spite of just creating one virtual machine and then in so you want to do it in Google Cloud Provider, GCP, AWS, Azure, and all the services that are available. So what you will do normally, if it in manual process, you go directly to that AWS console and then open the instance and then you install the first you select the AMI Amazon mission image, and then after that you will, once you logged into the system, you install the HTTPD, then you deploy the application, and then you run the service and you access the application. That's what the procedure. So whatever activity you have done, you put it in a template, you put it in a file. We call it as a configuration file. um, Either it could be in JSON format or it could be in HCL format, which is specific to HashiCorp configuration language. So either of this, you write it, so you make that file, we call it as image. Once that is ready, you can apply this image to any provider, either it could be GCP, or it could be Amazon, or it could be Azure, or it could be IBM. You can just apply it, so it acts like a template. The whole activities you used to do it manually, and you have to even for the manual procedure also, you have to change the way of doing, change the procedure with respect to the cloud provider. But here, no limitation. With one template, just change the name of the cloud provider inside the template, and then you just apply that changes to your configuration file. All set, all done. So that's what creating identical mission images mean. So uh, Packer is an open source tool, as we have said, for creating identical mission images for multiple platforms from a single source configuration. That's what I'm saying. From a single source configuration, the file is one. The file is one, but you can create identical mission images. So Packer is lightweight, runs on every major operating system, and is highly performant, creating machine images for multiple platforms in parallel. So Packer does not replace configuration management like Chef or Puppet or Ansible. So the most important point is, people think that it's gonna replace. No, it's gonna complement. It's not gonna replace, it's gonna complement the configuration tools such as Chef or Puppet or Ansible. It needs the support of those configuration tools to do that configuration automation. That's what happens. We will do it. We'll do that, and I'll show you in our practical exercises of Packer. So in fact, when building images, Packer is able to use tools like Chef or Puppet to install software onto the image. If you take the simplest example, again, you just want to run you just want to deploy a static web application in a server. This is what your problem statement. How do you do it in manually? So you log into any cloud provider, AWS, and then you create EC2 instance, and then you log into the EC2 instance, then you install HTTPD service in that, then you start and enable the HTTPD service in that, and then finally you deploy your application into the var www.html. In that you will put your index.html file, then your deployment is done. Of course, it requires 3 to 4 layers of manual activity. So what will we do is, we'll put all these manual activities into a Packer file, into a Packer configuration file. Installation will be done. Then so now, to provision a machine, one will do, and then after the provisioning, you have to install the services. To install and start and enable, so these activities are called configuration. In software language, we call them as a configuring the server. So this configuration will be done through example installation of HTTPD, and then starting the HTTPD service, and then running enabling the HTTPD service. These are all called configurations. To do this, normally to automate these tasks, we use Ansible. We have done it in our previous module, in our previous part of the third part of fourth module, that is Ansible. You just go there. We have done almost 2 to 3 exercises using Ansible. We have deployed 3 to 4 applications in that. You just go to that and watch it. its configuration. So here also, to do that configuration, you require the support of the configuration tools. Without that, it's impossible. So that's how we bring the configuration tool. So this packer will complement with the configuration tool, and then it will complete the overall process. So that we can create one image, one template, where it provisions the server, and then it configures the server, and then it deploys the server. Everything will be done with the only one template. That's the power of packer. That's the power of packer with the and configuration tool and then provision tool. So a machine image is a single static unit that contains a pre-configured operating system and installed software, which is used to quickly create new running machines. So machine image formats change for each platform. Some examples like include AMIs for EC2. For EC2 instances, we call it as AMI. For VMware, virtual machineWare, we call it as VMDK or VMX files, and for VirtualBox, we call it as OVF. And Packer has solution for all types. So now let's look into advantages of a Packer. So why use Packer? So pre-baked machine images have lot of advantages, but most have been unable to benefit from them because images have been too tedious to create and manage. So there were either no existing tools to automate the creation of machine images, or they had too high of a learning curve. So the result is that prior to Packer, creating machine images threatened the agility of operations teams, and therefore aren't used despite the massive benefits. So Packer changes all of this. So Packer automates the creation of any type of machine image. It embraces modern configuration management by encouraging you to use a framework such as Chef or Puppet or Ansible to install and configure the software within your package made images. In other words, Packer brings pre-baked pre-baked images into the modern age, unlocking the untapped potential and opening into new world of opportunities. Now, so the first benefit, the biggest advantage of using Packer is its super fast infrastructure deployment. So Packer Images allows you to launch completely provisioned and configured machine in seconds. This is what I'm trying to convey in even in my previous slide also. Not just normal. Till now what we have done, we have launched, we have provisioned, and then we have launched a machine, just a normal machine or a machine with an installed software. That's it. Or if you go a little ahead, sometimes we have using shell script we have launched, or using Vagrant also we can launch. Using Vagrant you can launch a virtual machine with deployed application, but if it is more complicated, it's difficult to do that. But here, using Packer, irrespective of how many servers that are working in coordination with each other, so it doesn't matter, still you can provision and then configure the machine in seconds and launch it. That's the power. That's the power of Packer. So rather than several minutes or hours, so this benefits not only production but development as well. So since development, virtual machines can also be launched in seconds without waiting for a typically much longer provisioning time. The second benefit is multi-provider portability. So because Packer creates identical machines, identical images or identical machine images for multiple platforms, you can run production in AWS or staging, or QAE in private cloud like OpenStack, and development in desktop virtualization solutions such as VMware or VirtualBox. So each environment is running an identical machine image, giving ultimate portability. Ultimate portability. Then the third one is improved stability. So Packer installs and configures all the software for a machine at the time the image is built. If there are bugs in these scripts, they will be caught early rather than several minutes after a machine is launched. That's the third one. It's improved stability. Then the fourth benefit of using advantage of using Packer is greater testability. After a machine image is built, that machine image can be quickly launched and smoke tested to verify that things appear to be working. If they are, you can be confident that any other machines launched from that image that we have created using Packer, it acts like a template, will be function properly with any kind of other provider. So Packer makes it extremely easy to take advantage of all these benefits. So what are you waiting for? Let's jump in and let's get started. So by now you should know what Packer does and what the benefits of image creation are. In this section, I will enumerate some of the use cases of Packer. So note that this is not an exhaustive list by any means. There are definitely use cases for Packer not listed here. So this list is just meant to give you a rough idea of how Packer may improve your processes. So let's begin with the continuous delivery. So continuous delivery, Packer is lightweight, portable, and command line driven. So this makes it the perfect tool to put in the middle of your continuous delivery pipeline. Packer can be used to generate a new machine images for multiple platforms on every change to Chef or Puppet or Ansible as part of this pipeline. So the newly created images can then be launched and tested, verifying the infrastructure changes work. So if the tests pass, you can be confident that the image will work when deployed. So this brings a new level of stability and testability and confidence to infrastructure changes. And the second use case is Packer helps keep development, staging, and production as similar as possible. That's why we call it as a dev prod parity. I gave an example of dev prod disparity that I have seen in my real life. Okay, so this Packer really helps to get that dev prod parity. Packer can be used to generate images for multiple platforms at the same time. So if you use AWS for production and VMware perhaps with Vagrant for development, you can generate both an AMI and a VMware machine using Packer at the same time from the same template. So mix this in with the continuous delivery use case above, and you have a pretty sleek system for consistent work environments for development all the way through to production. Then we have a third case is appliance or demo creation. So since Packer creates consistent images for multiple platforms in parallel, it is perfect for creating appliances and disposable product demos. As your software changes, you can automatically create appliances with the software pre-installed potential users can then get started with your software by deploying it to the environment of their choice. So packaging up software with the complex requirements has never been so easy or enjoyable, if you ask me, as it is easy now. So now let's look into the Packer terminology. So there are a handful of items used throughout the Packer documentation. So where the meaning may not be immediately obvious if you haven't used Packer before. So I will take you through the Packer documentation. So once I complete this, okay. So it consists of the main. It starts with the artifacts. What does an artifact mean? Artifacts are the results of a single build. Just note the words artifact. Build is the another word. You note this word, okay. And then and are usually a set of IDs or files to represent a machine image. Every builder produces a single artifact. As an example, in the case of Amazon EC2 builder, the artifact is a set of AMI IDs. AMI IDs, that is Amazon Mission IDs. So one per region. For the VMware builder, the artifact is a directory of files comprising the created virtual machines. This is the example of an artifact. The artifact is the output of the builder that's been built. So then build, the another word, the another term, build, BUILD, build. So builds are a single task, just a single task that eventually produces an image for a single platform. It's a single task, it creates a single image for a single platform. That's called a build. The output of this build is called an artifact. So multiple builds run in parallel. Example use in a sentence. Example uses in a sentence is the Packer build produced an AMI to run our web application, or Packer is running the builds now for VMware, AWS, and VirtualBox. Any example you can take, first one or second one. And second one, we are parallelly running builds in VMware, AWS, and VirtualBox. And the third term is builder. Who is the builder? Who is the builder? Builders are components of Packer that are able to create a machine image for a single platform. So builders read in some configuration, that's the configuration file, and use that to run and generate a machine image. So a builder is invoked as part of a build in order to create the actual resulting images. Example, builders include a virtual box can be a builder, VMware can be a builder, Amazon EC2 can be a builder. It's a Amazon EC2 is a service in Amazon Web Services. So that can be a builder. So these are the examples of builder. So far we have seen an artifact and then a build and then a builder. So build is a single task that eventually produces a single image from a single platform, and then the one which produces this is called a builder, through which it's been produced. That artifact is called a builder. So the builder can be an EC2 instance in Amazon Web Services, or VMware, or VM virtual, or VirtualBox in Windows. The third term is commands. Commands are subcommands for the Packer program that perform same job. An example of command is build, BUILD, which is invoked as a Packer build. So Packer is the main command. In that, build is a subcommand. So Packer ships with a set of commands out of the box in order to define its command line interface. Then the third term is data sources. Data sources are components of Packer that fetch data from outside Packer and make it available to use within the template. So example of data sources include Amazon AMI and Amazon Secrets Manager. And the most important term post processors. Post processors or components of Packer that take the result of a builder or another host processor and process that to create a new artifact. Examples of post processors are compress artifacts, upload to artifacts, and you can use Vagrant and some other tools as a post processors as a Terraform and all. So that's the post processor. If you see that builder, a post processor, these are the names, these are the terms we are going to use in configuration files. Then we have a provisioners. Provisioner is the one more term that we are going to use there. So provisioner, post processor, builder. So provisioners are components of Packer that install and configure software within a running machine prior to that machine being turned into a static image. So they perform the major work of making the image contain useful software. Example of provisioners include shell script is the best provisioner, then chef and puppet and ansible. These are actually configuration tools, but still these are the provisioners that you use with the in coordination in together with the Packer. So the last term that we have is templates. Templates are either HCL or JSON. JSON format we know. HCL language is a HashiCorp configuration language. So templates either you can write in either of this language. So which define one or more builds by configuring the various components of Packer. So Packer is able to read a template and use that information to create a multiple machine images in parallel. If you just put everything in one line, it begins with a template. Inside the template, you mention the builders, post processors, provisioners, and then once you execute that configuration file, either it could be a XCL language or JSON, whatever it may be. Once you execute that file, the builds that you mentioned inside the template will be executed, and the output that we get is artifact. Now let's look into the crux of Packer. That's the heart of the Packer. That's Packer command line interface. So Packer command line interface, before we look into the commands of the Packer command line interface, we are going to install the Packer in Linux machine. Once installation is done, so we will explore both parallelly. So Packer commands on one side, and then we will understand the structure of the Packer command line interface commands. Okay, for that let's get into the Amazon web service. Then let me click on EC2 instance. So I'm in Mumbai region. I will go to Oregon is better, I think. So let me get into Oregon. US West to Oregon. So in this Oregon region, we are going to open one in Ubuntu server. So launch instances, of course, we can launch the instance using Terraform template, using, so whatever the way you can do. But I'm just doing it manually here, and then we're going to apply Packer. So that's the reason. So I'll write this as a Packer machine. Then I'll go with, okay, I'll go with Ubuntu only. So it's not required. Ubuntu Ubuntu 20 is fine. Then yeah, I will go with T2 micro is free eligible chair. I'll go with the small only. Let's see, the cheaper option will go with it. Then create a new key pair. I'd say packer key. Create it. Then let's get into the network settings. Here I will create new security group, that's packer security group, and then copy the same in the description also. Then let me give the security group rules. One is through my IP as usual, and for this moment one is enough. If it is required, we will add another inbound security group rules later. Rest all fine. So in spite of going inside the server and apply using the commands to install the packer, we will give the packer installation commands and user data and see. But we'll get into the documentation of packer, and we will find out how to install. So packer package documentation, packer documentation. So this is the main packer documentation page. Here you can see on the top you have menu bar. First one, it take you to the documentation, then guides, then plugins, tutorials, and install. Okay, so let us, if you go to the documentation section, you'll find this all information, packer documentation, what is packer and how do you build images. You'll get some templates here, then packer CLI commands. So let me click on templates. It give you information about the templates. Either you can use JSON or you can use HCL. And if I take you to the, so that's about the templates. And now let's look into the pack commands CLI. So here you can get all the information about the CLI and then commands, sub commands and everything. So we will test it once the installation is done, then we will test it. And after that, if you see, you have guides in it. So here you will have welcome to the packer guides. If you're just getting started, please go through this. And you have HCL guides, automatic OS installs, and build immutable infrastructure with the packer in a CID. If you want to deploy, if you want to use packer in CID, so this is the procedure. So you can get it, that information also. Then you will find out the plugins, external packer plugins, and we use the official external packer plugin is that is HCP, HashiCorp Technology Partner Program. The package name is HCP Packer. So that's what the external plugins. And now tutorials, you'll have a lot of tutorials with the Docker, AWS, and then HCP Packer, then information about other ways. So those are tutorials. Now we'll get into the install. So here, this is the installation help page. So if you want to install your application in Mac OS, you follow this method. Windows, you do this, you download the binary file and then put it into the place. Or the simplest way, you can go with the uh, other way also using. So if, and you can use Choco also you can use. Or if you want to install in operating system, if you want to uh, deploy it in install it in Linux. So if it is Ubuntu is this, and then sorry, CentOS or Red Hat Enterprise Limited is this, Fedora, Amazon Linux, and Homebrew. So we have another free BSD, NetBSD, OpenBSD, and Solaris. So for us it's Ubuntu. Let me get here and copy this. Just scroll down a bit, nothing is there. So let me get back to our EC2 instance and paste it here. So before that, let me add shebang bin bash. So wget o option, and this is the URL. From there it's going to get the GPG. So GPG key rings, so that setting will be done automatically, so there is nothing to be added here. And after that, echo they want to print something, and then okay, this is also fine. And here sudo apt update and double ampersand means end, and after that it has to execute this command also, install packer. So I will give y. So everything is done. Now it's time, our piece of code has been put into the user data. Now it's time to launch the instance. Hope it gets installed. So it's done. Successfully initiated a launch of instance. So let me get into the instance first, and we will do SSH to that instance, and we'll check whether whether the packer has been installed or not. So it's taking some time. So it happens with my AWS account every time. The instance I create, it gets stuck, it gets hung for a few seconds. So let's wait for that. Once it's up, once our AWS responds, we will get back into the work again. Or else meanwhile we will look into the documentation itself. Okay, but it's absolutely struck. The browser itself is hung. Just wait for a few seconds. I think it will respond within few seconds. Anyway, the plan is for us, once the installation in packer once the installation of packer in Linux machine is done, then we'll get back into our packer commands, and we will look at what is command, what is subcommand, and what is machine readable output format, and what are the environment variables in it. All that information we are going to look into it. I think it still taking time. I don't know why, what's the issue there today. That's okay. Let's wait for few more seconds. Okay, finally the mission is packer mission is up and running. So let me do SSH into this. Okay, but before that, let me bring the uh, key pair. So I have downloaded that. Let me cut and paste it in a folder. So I think here it is. I will get into that. I'll find one place. I think it's like, that's my YouTube channel. Yeah, and then module part 4, and then hands-on. I'll put it in hands-on. So this is exercise 1, command CLI, packer CLI. So here I'll put it, and then here I'm gonna do bash, git bash, make it bigger. Yeah, now let me go to the connect SSH client and copy this command and paste it here and log into the system. Do SSH give S. So yeah, we are logged into our machine. So let me clear the screen and do sudo I, and again clear the screen. And now let me check my the installation of packer. So to cross check, let's begin with the command packer and then help. So use the command use packer version and packer help to bring the arguments. So let's give, so the packer has been installed, so these are the available commands. But before that, let me give version. In spite of this, I'll give version option. These are long options. So the packer version that we are using is 1.8.5. so Again, I'll give packer help. Okay, before that I'll clear the screen and then I'll use packer help. Yes. So these are the available commands with the packer. Let's get back to the system again. But before that, we'll get into the packer. So now we have seen the packer CLI. We have installed the packer CLI. Now let's look into the packer CLI theoretical point of view. So packer is controlled using a command line interface. All interaction with packer is basically is done via the packer tool. So that is this packer tool. You can see that I'll give a packer version, and this is the packer tool. So the packer tool takes a subcommand to execute, and that subcommand may have additional options as well. So subcommands are executed with packer subcommand. So where the subcommand is the actual command you wish to execute. So packer is the packer is the main command, and after that you write subcommand or init. If you put anything with options with hyphens, it's called an option. So here packer, and then packer is the main command and then subcommand, but here subcommand is the one which we wish to execute. So if you run packer by itself, it will help will be displayed. If you run a packer, help will be displayed showing all available subcommands and a brief synopsis of what they do. So these are the available subcommands: build, console, fix, fmt, hcl2, underscore, upgrade, init, inspect, plugins, validate version. We'll look into that one by one. What will they do? But before that, we proceed further. So basically, this packer CLI contains information about each subcommand. So, but here we have three types of outputs. So a machine, a readable output. So by default, the output of packer is very human readable. It uses nice formatting, spacing, and colors in order to make packer a pleasure to use. However, packer was built with automation in mind. To that end, so packer supports a fully machine readable output setting, so allowing you to use packer in automated environments. So because the machine readable output format was made with Unix tools in mind, it uses awk, that's a Unix utility, or GNU utility, and SED GNU utility, GREP grip GNU utility or Unix utility. So friendly and provides a familiar interface without requiring you to learn a new format. And how do you enable a machine readable output? So let's get into the documentation one more time. Where it is, here is that documentation. Go back to the documentation and click on the packer CLI. Here you see machine readable format. This is what, how do you enable a machine readable format? That's what you can find out here. We are going to enable a machine readable format. So what is machine readable format? The machine readable format can be enabled by passing the command, the subcommand -machine -readable and then space version. So with this we'll get the with this option, machine hyphen readable. With this option we can get a machine readable output. To enable the machine readable output, this immediately enables all output to become machine readable on std out. That's the output, that's the printing. So logging, if enabled, continues to appear on stdr. An example of this output we can see. Let me get into this and then make it left portion, and this is right portion. Let me clear the screen first and do packer machine option is readable and then version. Here it is. This is the way a machine can read. So here you can see version 1.5, that's absolutely fine, but here you can see the code. So this is what a machine readable version, the machine readable output. The format will be covered in more detail later, but as you can see, the output immediately becomes machine friendly. To write some other commands, you can use using the machine readable option. Okay, then what the third option that we have, okay, format of machine readable, and then we'll look into the format of machine readable. So the machine readable format is a line oriented comma delimited text format. Okay, it's a line based and then comma delimited text format. So this makes it more convenient to parse using standard Unix tools such as AWK or GRP grep, in addition to full programming languages like Ruby or Python. So now let's look into that formats one by one. So the will so we'll look into that format once. So let me get into this documentation. So come down, format for machine readable output. So let me copy this. So timestamp, target, type, data. This is the, okay, I just want to put, I forgot to put, yeah, paste it, space, copy, and then, okay, anyway, I just want to show this thing only. So these are the components of this is how, it's an example, this is how example of the format for the machine readable output. So example, in this example you have four components: the timestamp, target, type, data. So both, each component is separated by comma, or it's delimited by the comma. So in this, timestamp is a unique timestamp in UTC of when message was printed, and then target is basically when you call packer build, this can be either empty or individual build names. So example, if you take Amazon EBS, Elastic Block Storage, it is normally empty when builds are in progress, and the build name when artifacts of particular builds are being referred to. So that's the target. And then type, the third component is type. So type is the type of machine readable message being outputted. So the two most common types are UI and artifact. And the fourth component is data. So data is zero or more comma separated values associated with the prior type. So the exact amount and meaning of this data is type dependent. So you must read the documentation carefully so that you can get the clear understanding. So now let's go to the documentation one more time, and I want to give you more exposure on this. You can see that data and everything. So this is a machine readable message types. Either if it is UI, user interface, it looks like this. If it is artifact count and then artifact where, it looks like this. So let me check. So packer p auto build, if you want to add an autocomplete, so you have to do this packer autocomplete install. Okay, these are the information about the command line tool, CLI tool of the packer. So let me clear the screen, and now let's look into each command, or you can the sub command of the packer. So let's begin with the init command. So what init command will do? The packer init command is used to download packer plugin binaries. So this is the first command that should be executed when working with a new or an existing template. It's similar to Git, it is similar to Terraform. So you have to set up the directory, and inside the directory it's going to download the plugins. As it happens with the Git, as it happens with the Terraform, it will happen the same with the packer also. So this command is always safe to run multiple times, though subsequent runs may give errors. So this command will never delete anything. So packer does not currently have the notion of state like Terraform has. Basically, Terraform has state that we have seen. Once it is done, so it will bring up a state file .tf state. So okay, that state and then backup file. So that Packer does not have. So basically, they are working on it to bring this kind of that kind of functionality to the Packer. So let's go to this and just a minute. Yeah. Okay. So now let's execute our first command. That is Packer. And what is that command? It's init. What it does, so Packer init will list all installed plugins, then download the latest versions for the ones that are missing. So Packer init will also upgrade and will try to get the latest versions of all plugins. Let me execute this. So what we are missing, that we are going to see. So let me scroll up a bit. So Packer init, after that you have to give some option and then you have to mention the config.this. So then only it will install the respective plugins to that. So of course, when we are actually working on an exercise that we are going to use these commands, but for now we'll just see how it works. So that's the Packer init. Then we have the second command. It's init plugins. So the plugins command group subcommands are interacting with the plugins. So these are the subcommands of the this thing. So installs latest Packer plugins, and the installed, it lists all installed Packer plugin binaries, and removes Packer plugins and required list plugins required by the config that we are going to do in our uh, exercises. Okay, so then we have a build command. So this command, build command, the Packer build command takes a template and runs all the builds within it in order to generate a set of artifacts. So the various builds specified within a template are executed in parallel unless otherwise specified, and the artifacts that are created will be outputted at the end of the build. So then the example of this could be, of course, we do not have any here you see we do not have any config file of Packer, but still we'll run it and see. That's Packer, and then build Packer option H and then build. It depends upon which language you are using. It's saying Packer build option is fantastic, but you need to use template. So once you mention a template here, that's it. It will run all the builds that are mentioned inside that. So then we will move on to the next command, that is console. So the Packer console command allows you to experiment with Packer variable interpolations. You may access variable in the Packer config you call the console with, or provide variables when you call console using the -var. It's an option, or -var -file. This is another option, command line options with that. So let's get into the CLI again, and this time I will give Packer an H option and then say console, and after that you have to mention template Packer console sorry option, and then you have to mention template. This is the syntax of this command. I just want to show the syntax of this command. So either you can use this option, var key equals to value, or var file, you can directly mention the pack. So JSON or HCL to file containing user variables. Basically you have to mention the variables using this options. Then the fifth command that we have is fix command. So this command is not available on HCL2 templates. It's very important to remember. it will be added when we need to introduce the first fix. Okay, the packer fix command takes a template and then finds backwards incompatible parts of it and bring it up to date so it can be used with the latest version of packer. So after you update to a new packer release, you should run the fix command to make sure your templates work with the new release. So this is about the fixing the bugs and then taking up the new releases. Then we have the last but one uh, command, that's the inspect command. So why do we use inspect command? So the packer inspect command takes a template and outputs the various components of a template that it's been defined. So this can help you quickly learn about a template without having to dive into HCL itself. The command will tell you things like what variables a template accepts, the builders it defines, the provisioners it defines, and the order they will run, and more and more. So if you want to convert this command, you can add the machine readable option to that, so that it will be given, the output would be in machine readable output form. And then the seventh one is validate command. The packer validate command is used to validate the syntax and then configuration of a template, as we have done with the Terraform. In Terraform, we gave Terraform validate option. When we give the Terraform validate command, it has validated the syntax uh, of the uh, of the configuration file, Terraform config file. So the command will return a zero exit status on success and non-zero exit status on failure. So additionally, if a template doesn't validate, any error messages will be outputted. So let me click on and let me try to do that. It's packer validate. I do not have any template here, so it's given. It's not valid. The errors will be shown and the command will exit with a non-zero exit status. If it is valid, it will exit with a zero exit status. And then it's, where is that? Packer console, and here it is, packer validate. This is the usage, packer validate option. Here option comes, and then here you have to mention the template. So with this, we have seen the practical usage of the syntax of each command that we have mentioned so far, and the most important command. So let me get into the let me clear the screen first and then say packer and enter. So here these are the sub commands, or basically we call it as a commands in packer. So the first command is build. What does build? Build images from template. One done. Then console command, of course we have seen all this, creates a console for testing variable interpolation. So this connects within a variable file. If you have written variables separately, and you can connect your template with the variable file. Then fix, it fixes templates from old versions of packer and converts into the new. Then fmt rewrites HCL to config files to canonical format. It formats it. And HCL2 upgrade, this we are going to use. This is very important if you want to convert a JSON template into an HCL2 configuration, that we are going to use. We have one exercise on this also. So then we have init, so installs missing plugins or upgrade plugins. Then we have inspect, it see components of a template. And we have plugins, you can interact with packer plugins and catalogs, which can be internal or external plugins. Then we have validate, it checks that a template is valid based on the syntax rules. And finally version, prints the packer version. So let me print the packer version, that is packer version, because there he has mentioned as and sub command. So that's the reason I did not use it as an option. So that's it. This is all about the commands of packer command line interface tool. We have seen enough basics. Now it's time to look into templates and write some templates and execute some templates as a different number of exercises. So packer's behavior is determined by the packer template, which consists of a series of declarations and commands for packer to follow. So this template tells packer what plugins So basically it depends upon builders, provisioners, post processors to use, and how to configure each of those plugins, and what order to run them in. This template contains a flexible variable injection tools, as well as built-in functions to help you customize your builds. So historically, Packer used a JSON template, but the Packer is transitioning to a new template configuration format that uses capital H, capital C, capital L. So HCL2, the same configuration language used by Terraform and HashiCorp's other products. So this format is more flexible, more modular, and more concise than the original JSON template format. While the JSON format is still supported, certain new features in the Packer core will only be implemented for the new year HCL format. So please use the sidebar on the documentation that you find. So there, I'm just talking about the documentation. Just use the sidebar on the documentation to find out the conversion of JSON into HCL, or I will show you now only. Just a minute. I'll just show that once, and then this is our documentation. Let me get to documentation here. So if you see here, you can find out HCP Packer, and then Packer, just a minute, Packer CLI external plugins HCP Packer. So here these are communicators templates. You have a templates here. So in templates you have HCL template and JSON templates. If you click on HCL, let me go. So this is how HCL looks like. Anyway, we are going to talk about that. And then JSON Packer, you have to click on JSON Packer templates, or JSON templates, will get it. So this is JSON. Here you can see the JSON templates, and here you can see the JSON template structure. Okay, anyway, now we are going to work on JSON first. So now we are going to the Packer template using JSON format. That's what our initial exercise is. Once JSON is done, then let's move to HCL. Okay, so let's begin with the builder section. The builder section in Packer template in JSON format. The builder section is mandatory and contains all of the properties that define the image and its location. So such as its name, the type of image, the cloud provider on which the image will be generated, and connection information to the cloud, the base image to use, and the properties that are specific to the image type. These are the information that will be provided in the builder section. So within the template, the builder section contains an array of all the builders that Packer should use to generate machine images for the template. So builders are fundamentally responsible for creating machines and generating images from them for various platforms. For example, there are separate builders for EC2, VMware, VirtualBox, etc. So Packer comes with many builders by default and can also be extended to add new builders. So this is the syntax of builders section in Packer template in using JSON format. JSON. So open brace, open curly brace, and then close curly braces. In between you will have your builders section. So as usual, double quote builders section, and then it's similar as we have discussed in JSON format. It looks like JSON format, and inside that you have to add your builder definitions. Let's take the complete builder definition. So a simple builder definition maps to exactly one build. As if it is a single builder definition, a single and then simple builder definition maps to exactly one build. So in the inside that you will mention only one build. So a builder definition is a JSON object. So these are called, this complete this complete section is called as JSON object that requires at least a type key. So the type is the name of the builder that will be used to create a machine image for the builder. So in addition to the type, so the other keys configure the builder itself. For example, if it is AWS, builder requires an access key, a secret key, and some other settings. So these are placed directly within the builder definition. So this is one example. If it is a builder, AWS builder, then the type of the service that you are going to use, Amazon EBS, Amazon Elastic Block Storage, then access key you have to mention, secret key you have to mention. So this is how a single and a simple builder definition looks like in JSON format. So now let's continue with the builders section itself. Uh, so here, if we want to create the same image but on several providers, this is a multiple builders. So here we are going to use multiple builders, so we can indicate the same template file multiple block builders. The template file remains same. That's why we used to call uni resource. You will have only one resource, one configuration file, but you can use it for n number of builders. So we can indicate the same template file multiple block builders, which will contains the providers, which will contain the provider properties. For example, you just see the code that it's visible on the left side. So here we have mentioned two builders. So builders section, this is the object, it's a builder object. Inside that you have two builders. Inside the builder section you have two builders. The first one is Azure RM and the second one is Docker type. Location is Vestas, and then image that you have mentioned is Alpine latest. So this is how you can mention two or multiple providers. So in this code sample, in this code snippet, we define in the Packer template the information for an image of an Azure VM and the information for a Docker image based on Alpine. So in this exercise, we'll create an Amazon machine image for a Red Hat Enterprise Linux RHEL 8 using Packer. So we will use, after that we can use this AMI to deploy our custom AWS EC2 instances. That means we are actually creating our own images. Let's see how much we'll get success in this. Okay, so let me write the prerequisites for this. For that I will take a sticky note. Yeah, here it is. Go up, prereqs. So prereqs, what to create our own custom Amazon machine images with Packer. So we will need, the first thing is Packer. Packer should be installed in your machine. So I have installed the Packer in Windows machine. That's okay. Then after that you require AWS IAM user account with access key. That's user credential, basically user creds. That is access key, and then secret key. And what else is required? I think this is more than enough. So we have our packer ready. So let me clear the screen and let me show you packer. So packer I have installed it in our previous session, so kindly watch that session before you start working on this uh, practical demonstration. So my it's very simple. You just use choco install packer. So mine is it's there, so I don't need to install it again. So my packer is ready, so let me do the underline. So then I just cross that. Now let's work on AWS IAM user account. So let me get into my Amazon. Yeah, this is my Amazon, and then I'll click on IAM service. Yeah, it's taking some time. So now we will be taken to IAM. So I'll click on users. We have two users. This Terra admin is the one that I have created. This user I have specifically created for the purpose of Terraform demonstration. So the purpose remains same. So that's why I don't and now I don't want to create one more user. So if you have any doubt on this, you just go back to the Terraform module and you watch there how to create a user. Okay, so I'll use this user. I'll click on this user. So I have two access keys, but I do not know where it is. So what I will do is I'll create a new access key. For that, I'll click on security credentials, and then let me come down, scroll down a bit down. So here you see access keys. At this moment it has two access keys. So I have two access keys, so I cannot create one more access key. Or else what I can do is I can delete one access key. So I'll delete this access key. I'll deactivate it. Yeah, okay, okay. How can I have this? Yeah, just a minute. AKIA 23 EQPP G4TIJZ 7 GMG. Yes. Hope I should be able to create new access key. Yes, I can create new access key. Let me click on this. I'll select this command line interface option, and I understand the above recommendation and want to proceed with uh, create an access. That's absolutely fine. I'll click on next. Yes, description I want to give is this key is for um, Terra, sorry, Terra admin, and then this this access key is we are working for the packer, so I'll put packer. So Terra admin packer RHEL, this is what we're going to create. So create this access key. So it's ready. Now let me download this access key. Here you can find that. You click on download. So go to this and cut it and bring it into your folder. So before that, let me create a folder for this exercise specifically. So new, and the folder name I'm gonna give is rel ami JSON packer JSON exercise. Yes, let me enter, let me paste it here. Okay, so our first exercise, the first task. Yes, so user crates is also ready for us. Access key, so all these things are ready. So then once this is ready, so then the third step that we are going to do is creating a variable file, variable template. Then after that variable template, we have to create the main template, JSON main template, packer, JSON packer main template. Then after that, in this template, we have to add provisioner section also. That's important. And then you have to add one more thing, that is um, EMI, EMI ID, and then provisioner section. So then after that, so once all done, so then you can execute, or it's better to say build the AMI, and then validating the AMI creation. So these are the steps that we are going to do. So till now we have done with there's many steps. So while we are writing a variable template, so that time you have to copy the creds to the variable template. Okay, so let's build let's create our variable template now. So let me get into this folder. So here I'm gonna open with code. Yeah, so we have only one file at this moment. So now I'm going to, so our AWS credentials is done. Now we are going to create our variable file. So but what we do is, before we create the variable file, so I have to bring the various Amazon machines that belongs to the region that I want to see. Okay, let me get into this place here. So first one is done. Now list the AMS. That part I'm missing. Yeah. So here 3 list the AMS. So this will do, and then consequently we'll do the further steps 5, and then 6, and then 7. Okay. So let's list the images. So let me get into the Amazon and then take the piece of code that I have used. It's too big, and then copy it. Again, I'll bring up an EC2 Amazon Cloud Shell. That's AWS Cloud Shell. So I'm in North Virginia region. So here I'm going to paste this code. So what it says is so the AMI ID is required to launch an EC2 instance. So that's the reason we want to fetch that AMI ID using this piece of code. So to obtain the Red Hat Enterprise Linux AMIs list, so we have just opened our AWS console, and then in that AWS console we have opened the cloud shell, and then in that we have to copy this piece of we will paste this piece of code. So and then what it says, Amazon EC2 instance, and then describe the images that this owner consists of, and then query, and then it will bring all the images in a table format. Let's wait, it takes some time. Yes, it is. We got the Amazon images. So these are the description of the image here at the center, and then this is the time, and then here you have the AMI IDs. Okay, so we got this. So we have successfully done it. So after that, we are going to copy one of the AMI ID to put into our packer template. Okay, so this step is also done. So let me, okay, the list, the AMIs has been crossed down. Okay, so now the next thing is to create the variable template. So here we are going to create the variable template. So this is the place we are going to create the variable templates. So I'll create a new file called variables dot JSON file. And then now, so for what? To keep the values of AWS credentials and other variables such as AWS region, the EC2 instance type, the subnet ID, and the new AMI. So this all this information we are going to put here. So let me paste it here. So now I have to customize this file. So I need to get AWS secret key and AWS access key and region and then AMI name, instance type, and then subnet ID. So let me open the Excel sheet that I have downloaded, the credentials. Let me open this. Yeah, and then make it bigger. Yes, this is the access key ID for us. Let us copy this and then get into this. So here I'm gonna paste it. AWS access key. Okay. Yes. Now we require AWS secret key. So let me copy from here and then paste it here. This is our AWS secret key. So now let's decide which region you want to go. I'll just check. Wait a minute. It's here. So EC2 instance. So I'll get into the, okay, this time I'm going to go with, okay, I have done some exercises in North Virginia, so I will go with the US West one, North California. This time I'll go with the North California. Okay, so there are no AMIs here that basically custom made, or the AMIs that I have made. That's the reason. So at this moment there are no AMIs. We will build the AMI and we'll see. Okay, so now we are in North California. It's US West. You can see this, or I'll get into instances so that you can clearly see. Okay, so it's US West 1. So I'll copy this from here and then we'll paste it in our code. So I'm going to use US West 1. Yes, this is done. So now AMI name I want to give is rel 8. So Charan AMI. I have created this. I say Charan AMI. And then T2 micro is absolutely fine. Then subnet ID. I have to give the subnet ID. So now I am in US West 1. So US West 1. To get it, I'll go to the global view, EC2 global view. No, it's not required. I can get it here also. Okay, so I'm in North California. So I'll click on any instance or launch instance. So here is the AMI. I'll find the, yeah, VPCs here. Let me click on edit settings and okay, I'm supposed to get it. AMI, that's okay. That's fine. We'll get into the EC2 and then global view. Global view, that would be better. Yes. No, even in the previous, yeah, dashboard. This is what I want actually. This dashboard view. EC2 dashboard view. This is what I want. So now this is in North California, US West 1. So I'll click on, you can see US West, North California. This is our VPC. I'll go to this VPC. Yeah, it's taking some time because network here is pretty slow. Okay, so now we are in, okay, this is Amazon EC2 US West 1, and then let's click on subnets that belongs to US West 1. So US West 1 consists of only two subnets, that is US West 1C and US West 1A. I'm going to select the top one. So US West 1C, and I'm gonna copy the subnet ID of US West 1C, and then I'll put it in our, yes, our subnet ID is ready. So by and large, our variables.json file is absolutely ready. So now it's time to jump into creating the Packer template file. Okay. So let us, so we have created a new file called variable.json. So now we are gonna create a new file called rel8.json. So basically this is rel 8, and then I'll say packer, and then it's a JSON type, so I'll name it as a JSON type. So rel 8 JSON packer, and then I'm gonna build the, so now we can create the AMI using a hardcode ID or source AMI filter. So we will go with the hardcode ID. In spite of going through the source filter, mentioning the virtualization and all kind of things, we'll just simply give the AMI ID. That would be easier. Okay, the hardcore image ID is recommended when we want to lock the AMI ID for all deployment to specific AMI version. But the source AMI filter is recommended when we want to build an AMI using latest version of the operating system. And at this moment, this is just for demonstration. I'm not worried about all those things, latest version and the old version. So I will go with the hard code, yeah, image ID. Okay. So let me let me add the code now. So this section, this is the total section. Ours is, it consists of two sections: builder section and then provisioner section. So if you remember this exercise, you see the previous exercise with the Azure variables, and then variables, builder section and provisioning section. This is what our mainly packer template. Okay, so that's what we have put the same here. This is our builders section. In that, the type is Amazon EBS, that's default, we'll put it. And then access key has been basically referenced through variable, so you don't need to touch the access key and secret key because we have put it in variables.json file. It's not, you don't need to touch it. And then a region also, the name of that variable is AWS region. You just check it, it's AWS region. So it's been referenced using a variables, you don't need to touch it. And even subnet ID is also been referenced using the variable, so you can see that it's subnet ID. So now EC2 instance type. So here the source AMI, that's what I'm saying. What will we do? So you have two options. One to go with the hard coded source AMI, other one is to do the filtered source AMI. So we will go with the hard coded source AMI. For that, I will get into the uh, EC2 instance of this one. Okay, I'm in this VPC cloud. So let me, so this is not California. So EC2 instance, this is US West one, correct? Now launch an instance, and let me take an instance. I'll take rel. Here it is. Okay, so this is the AMI ID I want. I'll just copy this. Okay, just a minute. uh, either ARM or 86. I will go with the X86. I'll copy this, and then I will put it here. So AMI source AMI, this is the source hard coded AMI. So then instance username, I will give EC2 Charan. Then SSH timeout 60 minutes, that's more than enough. Then AMI name, we will get into the variable file, and AMI name is the one Charan rel 8 Charan AMI. So that's how we have added. So builder section has been completed with all the information: type, access key, secret key, region, subnet ID, instance type, source AMI, SSH username, and timeout and AMI. So now let's work on. After this, we are going to look into provisioners section. So the provisioners use built-in and third-party software to install and configure the machine image after booting. So provisioners prepare the system for use. So common use cases for provisioners, basically mainly it's used for the installing packages in the in that machine, and patching the kernel, or creating users, or downloading the application code, or deploying the overall application. So this kind of activities that we do using either third party or using any provisioner. So packers include several provisioners such as shell executed on the remote machine, and then shell local executed on the local machine, ansible local, ansible remote. These are some of the examples. So in this example, in this practical demonstration, we use a shell provisioner in our packer template that you can see here. So I have used the type shell provisioner. So the shell provisioner runs commands on the uh, that Red Hat Enterprise Linux machine. So in this case, we execute the pwd command. That's it. I just want to get the present working directory where it will land up. Obviously, it will do SSH through EC2 Charen user. So that means it should be in the home directory of EC2 Charen user. What is the home directory of EC2 Charen user? It's /home /EC2 Charan. Let's see what's going to happen. This is our validation point. Okay, fantastic. So now our file is ready. Our template is ready. So let me save this template. Our variables.json file is ready, and then access is also ready. Let me cross check what all things we have done so far. So variable template is done. Copy the creds to the variable template is done. JSON packer template, AMI ID provisioners also had been added. The AMI ID is hard coded source, hard coded source name, that name ID we have given, and then provisioners is also done. So let me cross it, and then now it's time to build the AMI. Okay. For that, what I will do is, in this directory, I'm gonna open git bash. Let me zoom it. So let me check. Packer is available. Yes, absolutely, packer is available. And let me check the packer version. Yes, packer version is also there. So now let's build it. So give packer build, and then a variable name, because we have used the variable. So let's integrate that variable with the packer template, that variable template with the packer template. So var, and then hyphen file, a long option we have used, equal to variables dot json. Okay, variables dot json. And then what's the template name? Our rel8 packer.json. So let us execute and see what is going to happen. Amazon EBS output will be in this color. That's okay. The first activity, Amazon EBS pre-validating any provided VPC information. It's pre-validating the virtual private cloud information, and then pre-validating the AMI name. So AMI name we have given is rel8 Charan AMI. Then it found the image ID that we have mentioned. Fantastic, superb. So this is the image ID. So it has found. Now it's creating temporary key pair. Obviously it's not permanent because it's just an image. Right? And after that it's going to close the mission that it has created, and then creating temporary security group for this instance. So this the temporary security group ID is this. Then after that, now it's trying to access the machine in the EC2 instance that it has created, the uh, through port 22 and from 0.0.0.0 forward slash 0. This forward slash 0 is it is CRDA, and then this one is the IP. So if you have no clue what I'm talking about, you just go to my networking module and see I have explained very clearly. Then so this is now it's trying to authorize from this port using this IP and using the temporary security groups that we have mentioned on top. So now it is launching. The next step is it's launching the AWS instance, the instance ID. That means it has been launched. AWS, congrats, the AWS instance has been launched. So with an instance ID, the instance ID is this. So now it's waiting for instance to become ready. So it takes some time to do all the settings inside that. Once instance is ready, then it's using SSH communicator to connect. This is the IP. So 54, it's public IP. If it is 170 and around, it's a private IP. So using the public IP, it is connecting with that machine. Now it is waiting for SSH to become available. So again, so thus far, validating the VPC is done, then pre-validating the AMI name is done, then it has selected the AMI ID, then after that it has created temporary key pair and then temporary security group, then authorized, then it has authorized that machine using port 22, then it has launched the AWS instance, then instance ID, and then it's waiting for the then finally using SSH, it's communicating, it's connecting with that machine. So after that, the provisioner comes into the picture and it has to do its activity. So let's see. Let's wait for system to respond. So I'm not going to do anything more. I don't want to disrupt that. Let it happen. Of course, it's taking more time. I don't. This time it's taking more time. Yep, it's connected. Uh, waiting for the SSH to become available, and then our user EC2 user has been connected to the SSH. So now the next thing is provisioning. So till that this piece of code is done, the builder's code is done, it's been executed. Now after that, after once it is connected to SSH, then the shell has come into the action. Then the shell, what it has done, in this location the shell was there, this is the shell, it's been used, and we have asked, what did we ask to do? We asked to execute pwd command. So pwd command has been executed and it has given this address. So this is forward slash home forward slash ec2 user. So what this is what I have told you in initial stage of my video, that it should land up because it's going to access that ec2 instance using the user. So this user, ec2 user, that means it has to land up, the present working directory should be home directory of the ec2 user. That's what it's been proven. So the point has been validated properly. So now once the activity has been executed, once the command has been executed, now it's time to stop the source instance. Then the instance has been stopped. Now it's waiting for the instance to stop. So now it's creating the AMI, Amazon machine image. The name that we have given is rel 18 Charan AMI. So let me take you there. Variables dot. So this is the name that we have given. Yeah. And then so now it's creating that from this instance. Now AMI with this AMI ID has been created. Now it's waiting for AMI to become ready completely. So now skipping enable AMI deprecation. Okay. So it's skipping the deprecation, AMI deprecation. Okay, that's anyway not that important. Now it is terminating the source AWS instance where uh, 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 so it's like a temporary instance has been launched, and it has created that AMI. Now it has to terminate that instance because the whole purpose of this activity is to create an AMI. Once the AMI has been created, now there is no point of keeping that instance. So that's when the instance has been terminated. Now it's cleaning up any extra volumes. Now no volumes to clean up, skipping. So everything is done, deleting the temporary security group, deleting the temporary key pair. So to build this, it took almost 3 minutes 20 seconds. It's huge time, in fact. So for the whole process, it took 3 minutes 20 seconds. Now wait, complete. Okay, that's fine. So build finished. The artifacts of successful builds are, so if you remember in our initial stage of this module, this part of module, we have discussed the terminology of a packer. In that we said artifact. This is what the artifact is. So Amazon EBS AMIs were created with US West 1 and then with this ID. Let's get into the AWS console and we'll check whether it is available or not. So this is our, we are in North California, that is US West 1 zone. So let's click on AMIs and see what's going to happen. I'm just curious to know whether we'll, yes, that's it. Congrats. Here is rel 8 Charan AMI. The AMI has been created. Now it's all up to you. So even you can create your, so even you can create your own AMI, and this AMI, so if I want to launch an EC2 instance, I can use this AMI ID, and then I can launch an my customized EC2 instance. Let me do a bit of modification and let me create one more AMI. So here, so rest all is fine. Okay, it's not much to do. Variable, yep, everything fine. So there is nothing much to do any modifications. Yep, all done. So if I create one more time, it's going to create one more EC2 instance. So that's how it actually works. So we have successfully built an Amazon machine image, our own Amazon machine image. So congratulations whoever is following this, and if you are able to also create this, it's a big congrats for all of you guys, because you have made it. Now you have created your own Amazon machine image. So before we wrap up this demonstration, I would like you to take you through the uh, documentation of JSON templates. So you just come here, you see this URL, and then just click on JSON template overview. Of course, we have done all this. So JSON template structure consists of these most important topics: builders, and then post processors, provisioners, and then variables. So we have used variable template, builders, and then provisioners. So example, let's take, so if you take one example of that they have mentioned is AWS. This is our, basically this this is our inspiration to make that file. Okay, from here only we have taken the inspiration. You see, type Amazon access key. Instead of directly giving access key, here what I did is I have created a variable template and then I have referenced it, and rest all it's normal. So same thing we have used. Source AMI, you can directly mention the AMI, and then provisioners shell and then script. In spite of that, I've just put the pwd one thing, or else you can directly put a shell script where you want to deploy an application. So it will execute that and it will deploy that. So you can create a AMI where you can deploy the application directly. So it's all fun, it's brilliant. So now you can go to the builders section. So here you'll find all the rules and how to define and how to build the builders, and how to and you can look into the communicators also. So here it's a detailed communicators template. And then engine. So then from engine, here you will find a ways, like the syntax of templates uses the conventions, like if you want to attach a variables, so this kind of information you can get it from here. So then you have a post processors after the work. If you want to attach any other tools such as a Vagrant or any other tool, so that can be attached using the post processors. Okay, so then we have a provisioner. So we have used the provisioner section anyway, so that we have used, there are different types of provisioners, but we use the shell type of provisioners like this. Okay, so and then user variables, that's it. So if you want to do more, so you get into the external plugins and you get into this guide of Packer. So here you can see all, you will get the templates for all. So Alibaba Cloud, Anka, Ansible, Amazon EC2, and then Azure, Chef, Cloud Stack coverage, Git, Google Cloud Platform, GCP, everything by and large, everything you'll get, even Vagrant, VMware. So if you click on Amazon EC2 instance, so there you will find, so let me click on different examples. So how to get the EBS, how to make EBS volume instance, and if you click on Azure, so you can get into that Azure ARM. For example, you want to create an ARM, so like Azure Resource Machine image. So you'll just, it will give you the complete information and how to create, and then it also give you the snippets in JSON format as well as HCL. Anyway, we are going to look into HCL. As of now, we haven't seen how HCL looks like, so that's why I'm not talking about HCL here. So the JSON format, you can see this is how you will create your ARM. So and then, so that's how. So you have a lot of examples here, a lot of example. If you want to become an expert of Packer, you just go through it, and it comes it is useful, very useful for us. It's pretty useful for us. We have seen the theoretical concepts of writing the Packer templates using JSON format, and then we have done the practical demonstration of creating an Amazon Web Services image AMI using again Packer template of JSON format. So now we are going to look into Packer template using HCL, basically HCL format, and we will see the theoretical concepts first, and then we will jump into the demonstrations. So Packer uses the HashiCorp configuration language, that is HCL, so which is designed to allow concise descriptions of the required steps to get to a build file. So this session or this slide describes the features of HCL too exhaustively. If you would like to have a uh, quick if you want to have a detailed explanation and detailed information about HCL format, and go to the documentation of HCL, I'm going to show that. Okay, so let's begin with the builds. So the main purpose of HCL language is defining the builds and resources. All other language features exist only to make the definition of builds more flexible and convenient. So the most important aspect is Packer build. So Packer build takes one argument. So that argument, when a directory is passed, all files in the folder with a name ending with either .pkr.hcl or .pkr.json, either of which will be parsed using the HCL formats. When a file ending with .pkr.hcl or .pkr.json is passed, it will be parsed using the HCL to schema For every other case, the JSON only old packer schema will be used. So you have these two extensions that we can use to save our template in packer. So let's see the syntax of HCL language, which consists of only few basic elements. That is, it begins with a source. You can see that it's a block, it's a complete one block, and then that begins with a source. It's a block type, and then it consists of a block labels. Amazon EBS is one label and an example is another label inside that block. So the block opens with a curly braces, and inside that you will have an argument. So AMI name is the argument. So this is basically similar to the Terraform, because even Terraform uses the same language. HCL has HashiCorp configuration language. So blocks are containers for the content and usually represent the configuration of some kind of object like a source. So blocks have a block type, can have 0 or more labels and have a body. This is the body that contains any number of arguments and nested blocks. So most of Packer's features are controlled by top level blocks in a configuration file. Then we have an argument inside the block or inside the container. So arguments assign a value. This is the value to a name, so they appear within the blocks. Then we have expressions. So expressions represent a value either literally or by referencing and combining other values. So you can give a referencing to the variable file. So they appear as the values for arguments or within the expressions. So then we will look into HCL comments. So we can add HCL comments here. So for that we use either forward slash, double forward slash symbol, or pound symbol, or a forward slash asterisk and forward slash asterisk. So either of these symbols you can use to add comments in Packer. So then we will look into the multi-line strings. Using this way you can do the multi-line strings can be attached to our to our uh, to our template, packer template file. So building blocks can be split in files also. So if you want to split into two different files, so this is sources.pkr.hcl, this is one file, and this is build.pkr.hcl, this is another file. So this consists of a source and this consists of a provisioner information. Still you can attach using this concept. Okay, so now so what will we do is we will go for the documentation and we'll go through it quickly, and then we will do some exercises. Okay, so provisioners, how to build. Okay, build an image. Yeah, here only. So I'll get it into the uh, templates, and inside the template HCL. So this is the overview of it. Consists of builds, arguments, blocks, and expressions. And then if you want detailed information about everything, you just go to the blocks. Inside the blocks you will get more information, so what kind of blocks you can have. So overview of blocks. So there are different types of blocks. The most important blocks can be broken into couple of major types. The first one is build. So what is a build? Build blocks contain a configuration for a specific combination of builders, provisioners, and post processors used to create specific image artifact. So a build block consists of specific information about all other blocks. And then you'll have a source block. Source blocks contain configuration of builder plugins. So once defined sources can be used and further configured by the build block. Source, we're going to see what is that. And then provisioner. So provisioner, it's similar to the JSON. So provisioner blocks contain configuration for provisioner plugins. So these blocks are nested inside the build block. Then we have a post processor. So what's the purpose of post processor? So post processor block contains configuration for post processor plugins and then post processor plugin sequences. So they are also nested within the build blocks. So then you have a variable block. So variable block contains configuration for variables that can either be defaulted in configuration or set by user at runtime. So these are some of the blocks that we use widely, and then we have a config file just to give an example, and you will save the file name as this variables.pkr.hcl, and then locals and more examples are attached. The source block, a build block, and there are a lot of examples are given. Okay, that's about the blocks, and now let's look into the functions. So it's in depth, so I'm not uh, going into each and every aspect. You just go through it. So these are built-in functions. You can make your function like this maximum 5129, and then it will give you the maximum out of it. So in that you have a contextual functions, numeric functions. So it's similar to the apps, seal, floor, log, max. These are all built-in functions. These are Python. Let me click on apps. See, this is how it looks. Apps absolute function. It will give you the absolute value, though if we give the negative value. So po and minimum, maximum. So then we have a string functions. These string functions are to joint, indent, regex, title, trim space, upper, so all those things. And then collection functions, encoding, file system functions, base name, file exists. So by and large, this is way more advanced than just JSON format. So that's the reason now we are completely leaning into JSON, into HCL format, so that you have huge amount of functionality. You can see the path variables, contextual variables. Okay, that's variables, but you have seen the functions. You have a lot of functions. If you go to the IP network function, CADR host, you can see that. So to even to give the CADR host, you can use this function CADR host, and you mention the prefix and then host number. That's it. It's actually fantastic one. And then CIDR netmask directly prefix, and here you can mention the subnet even, CIDR subnet. So it's magical and it's fantastic and fantabulous. So HCL is very helpful. You have a lot of huge amount of functionality. Then you have type conversion functions like can convert. You can use try. So convert function converts a value or an expression to a given type, that whatever type you want to convert, that can be converted into it. So it's like a proper programming language, not just a format, not just just a script type. It's a proper programming language which consists of everything. So let me come. So if you look into the overview, the main aspect is blocks, and we have seen the different blocks in it. Then it consists of functions. There are a huge number of functions. A default or inbuilt functions is attached with this one, and then we have variables. In variables we have different types of variables, and then we have a local values, contextual variables, data sources, and path variables, and then finally the HCL configuration syntax. So this is how it consists of. So you just go through this more and try to understand this, because it's very powerful tool. Because this HashiCorp uh, corporation, this company is absolutely completely, they're coming up with their innovative tools, and they're using their own configuration language. If you learn this language, it would come in, it would come to your rescue whenever is required. Okay, just go through this one. It's a fantastic documentation they have given. So you can see all the tools that are mentioned, all the components that we are going to use in the script, in the HCL has been mentioned. So it takes to the installation. I'll click on Windows, and after that scroll down a bit, and then click on getting started with a Docker. So this Docker exercise consists of this image, this much of exercises in it. So I will begin with installation of Packer. So to install the Packer manual way, for Mac or Linux or Windows, the logic is very simple. You download the binary file and then attach with the path, and you download the binary file, place that binary file inside the C drive in a certain directory, and then copy that directory and uh, paste that directory in the path environment variable. That's it. This is how we do. This is how we have done for the Terraform, and the same way you have to do. But this time I want to go with the Chocolatey. I want to go with the automatic installation. So Chocolatey is much easier, but you should have this package manager in your system. So I have installed this Chocolatey well before, maybe 2 years back. So so you also install this Chocolatey. It would be much easier to handle a lot of softwares in Windows machine. So I'll copy this, and I will go to the uh, Windows PowerShell and run it as administrator, and I'll give S. So it's up. Clear the screen and paste the command, and I'll put Y option. Chocolatey version 1.1.0 I have. So now installing the following package, that's a Packer, and Packer has been downloaded 100%. So now the Packer has been version 1.8.4 is being installed in my machine. So it's going to take a bit of more time because it's 1.42 MB has been done, and then 31.42 MB has to be done. So now I'll get into the documentation once, and I'll show you. So total, so here we are going to do six tutorials, out of which the first one is installation of Packer. Once the Packer installation is done, then we have to verify the installation. To verify the installation, again we'll do, after installing Packer, verify the installation worked by opening a new command prompt or console and check that Packer is available. That's what the verification we are going to do. And then once verification is done, we are clear that we have the Packer in with us. So we will continue to the next step. Then the second exercise that we are going to do here is building an image. So building an image. So here we are going to write a Packer file. The first Packer template, we instead of calling a configuration file or something, we will call it as a Packer template from now onwards, so that it would be much clearer. So Packer template, we are going to uh, create a Packer template. So this Packer template consists of a first block. First section is Packer section, and then after that we have the source section, then the build section. So this is about our file. Okay, so once it is done, once we have written it, then we will do Packer in it, and then Packer format, Packer validate, and then build it using build command, and then the file. So then finally we'll check what is going to happen. This is our second exercise. I think first exercise is done. No, it's taking a lot of time, 15.17 MB. So it has to be it takes I think 3 more minutes. Let's wait for that. Once installation is done, then we will go for the second exercise. So now the first exercise is going on. So once it is done, then we'll go for the second exercise in this. So it's done now. So the Packer has been the installation of Packer was successful, and the Packer has been installed successfully. So now let's validate the installation of Packer using the first command we are going to use is Packer version. Just give version, Packer version. So here it is, the Packer version is 1.8.4. so your version of Packer is out of date. Okay, that's fine, it's not an issue. So the latest version is 1.8.5. That's fine, it's not a big deal. Okay, so then clear the screen and do one more thing, that is Packer and enter. So that's it. So this is how to use the Packer commands. This is the syntax of the Packer command. It begins with the Packer, and you can use a version or any option. These are options, and then you can have a command in between a command and then sub command. You can have your options, and then finally, if you want, you can add an argument. Obviously, our template name is an argument for us. So with this command, an option, subcommand, and arguments. So that's the syntax of our Packer Packer command, Packer commands. Okay, so now all done, all set. The first exercise is being done successfully. Installation of Packer in Windows machine, it's done. So now it's time to enter into second exercise, that build an image. Build an image. So to do that, what I will do is I will go to this folder. So here I have created the Packer tutorial, and I will create one more folder here, that is Packer exercises and DevOps for you. So let me open it. So here we are going to write our first exercise, but I'll write the folder name. So it is build exercise. This is build exercise, that's it. So sorry, I'll change it as build exercise 1. In this I will open using VS Code, and I'll write the file. So the file name I'm going to give is a Docker, and then Ubuntu dot pkr, that's pkr is packer dot hcl, that's the name I'm going to give. So the file name is docker ubuntu dot pkr dot hcl. Yes, your file is ready. So let's start writing the blocks. So now let's begin adding the blocks. So add the following block to this. The first will begin with the Packer section. So Packer, and then space, braces. So inside that we will write information about plugins. So required plugins for us is required plugins we are going to mention. So what is that? Docker is our first plugin, and then so we have to mention the information about the Docker, because here we are going to use a Docker plugin only, so that's the reason. So Docker and version of the Docker should be greater than or equals to 0.0.7, and then close the quotation. Then source, from where do you want to get this file? From github.com of HashiCorp Docker. Yeah. So this is the source and this is the version. You go there to the source directory, source repository, and you find Docker there and you download it with the version anything which is greater than or equals to 0.07. This is our first section. The first section does is bringing the required plugins. Okay, our first section is done. Now it's time to look into second section. So here we are going to write about the source section, and then source, so Docker, Ubuntu. So image name that we are going to use is Docker. Image that we are going to use is Ubuntu colon, and Xenial is the tag, and commit equals to true. This is a boolean one. So this is also done. Now let's write the third one. This is the build one, the most important one. Build one. Without this, it's impossible to build. So name, I want to give um, intuitive DevOps for you. Intuitive DevOps for you Packer build tutorial. So this is what our name of the build. Then sources that you want to use is, of course, a list of sources we are going to use, but one source is source dot docker dot ubuntu, and then close this. So this is our complete file: Packer section, source section, and then build section. So basically it brings the uh, Docker plugin, then it pulls the Docker image, that is Ubuntu image, and then remaining thing is it will build it at the source.docker.ubuntu. So let me close this one, save this one, and then close it. So here is that file that you can find out. Okay, in this I just want to go through these things one by one. The first block, if you can see the packer block. The packer block contains the packer settings, including specifying a required packer version. In addition, you will find a required plugin. So block requires plugin block in the packer block, so which specifies all the plugins required by the template to build your image, even though packer is packaged into a single binary. Then we have a source block. The source block configures a specific builder plugin, which is then invoked by a build block. So source blocks uses builders and communicators to define what kind of virtualization to use. So how to launch the image you want to provision, and how to connect to it. So builders and communicators are bundled together and configured side by side in a source block. So then the final one that you can see in this example is so if you see the source block here that I have mentioned on the on this file, in this template, the builder type is, what is the builder type that we have mentioned is Docker. The builder type that we have mentioned is Docker, and then the name we have given is Ubuntu. Okay, so each builder has its own unique set of configuration attributes. So the Docker builder starts a Docker container, runs provisioners with this container, that then exports the container for reuse or commit this image either into any kind of repository that we have mentioned as a post processor. So in this example, the Docker builder configuration creates a Docker image using Ubuntu Xenial. So that's the image that it's going to create, and as the base image, this is the base image it's going to bring, and then commits that container then to an image. So then we have the build block. The build block defines what Packer should do with the Docker container after it launches. So in this example, template, a build block references to the Docker image defined by the source block above. So that's what is a complete, a detailed description about the each section that I have mentioned in this file, uh, in this the template. In spite of saying file, it's better to say template. So let me save this one, and it's time to initialize the Packer template configuration. For that, let me open a git bash in this section. So git bash, and then maximize it. Okay, so now here let us check whether Packer available or not. Packer space enter. So usage of Packer, so that means Packer is absolutely perfectly available. So now it's time to initialize our Packer configuration. That's the first step. To initialize your Packer configuration, you have to type Packer and then init and then so the Packer initialization has been done. So Packer will download the plugin you have defined above. So in this case, we have mentioned that the plugin could be anything which can be greater than the version 0.0.7. So we have run the packer init as, so you can run this packer as many times, packer init as many times as you would like. If you have already, you have the plugins you need, so packer will exit without an output. So that's it. We have run it before, so it's not going to run it again and again. So I have run it before, so uh, uh, is even if you run it again and again, so it's going to exit without any output. So Packer has now downloaded and installed the Docker plugin, so it's ready to build the Docker image. So now, but before that, let's format the uh, Packer file. Let's format and validate our Packer file. So always I recommend using consistent formatting in all of your template files. So for that, we have to use Packer and then fmt dot. So this command updates the templates in the current directory for readability and consistency. So format your template always, and Packer will print out the names of the files it modified, if any. In this case, your template file was already formatted correctly. So you can see that it's been formatted correctly. So when I do it again, it's not going to print the name of that because it has already been formatted. So Packer a Packer did not return when I gave format again. So this time it did not give. So now we have to make sure our configuration is syntactically valid and internally consistent by using the Packer validate validate dot command. So it says validate. So we validated our template, and it has detected, if Packer detect any invalid configuration, Packer will print out the file name and then the error type and the line number of the invalid configuration. But in our example, the Packer file that we have, the template file that we have provided is absolutely fine. It has printed the configuration is valid. And let me clear the screen, and so we are ready to build our image. So build our Packer image. So build the image with the Packer build dot. So basically the dot is argument. So I'm saying uh, this current present working directory has a file. You go there and find a file with the extension dot pkr.hcl. So Packer will print out the output. Let's look into that output. What is going to be printed? So packer build dot, so demonstrate HCL packer dot docker dot ubuntu, so that's fine. So as the demonstration has been begun, so it's creating a temporary directory for sharing that. So here you can see that pulling the docker image ubuntu with the tag xenial, and then it's pulling that image from there. The pull is completed, download has been done, pull is absolutely completed. So of course it's been finished. Let me go up, and I just want you to go through the each step so that it will be much clearer for you. So where is that? Yeah, here with this the pull has been completed, and this is the name of the layer, and then file name, the complete, and then download the newer image for this, the docker. Then it's starting the docker container also. Then so it's running a docker using this command, docker run -v, and this is the location, and this is the image that has been mentioned, and then finally this is your container with an id. And so after that the container has been committed, and you can see that the image id, and once it is done, it's the killing the container has been killed. And then finally, so wait completed after 20 seconds and 761 milliseconds, builds finished. The artifacts of builds are this. So let me look at docker images. You see there are two images, and let me give docker ps. There is no container, so two images because the containers has come up and has gone. So this is okay, no container. So let me get into the docker, and you'll see the images. You see here the ubuntu image with the xenial, and you can see that image. And let me go to the containers. There is no container, but image has been created. Okay, so that's how using using a packer template you can even create a docker image. So if you want to delete this image, if you want to delete this image, the only thing is you have to use docker commands. I hope if you do not know about the docker commands at this moment, don't worry. So whatever command that I'm giving, just use that command. Anyway, in our next module, next module, in the sixth module, we are going to discuss about the docker in detail. We are going to do a lot of exercises. Okay, so at this moment I'm going to delete this file docker rmi, and then image id I want to copy. So I'll copy this image id first and then paste it. So there is no container attached to it, so it's been deleted. So then let me check the docker images, how many images are there. So one more image, that's xenial. So I'm gonna delete this also, docker rmi, and then image id is b. Okay, I can use tag also, no? Xenial. Okay, that's repository ubuntu I can use. Copy and then paste it here. Done. So with this we are able to successfully demonstrate building an image exercise also. So we have installed the packer, and then we have also uh, we have also built an image using the packer template. So now let's do the third exercise. So installation is done, build an image is done. So now let's do the provision. Let's add provision to the template. Okay, so for that we'll create a new directory here. So I'm here, so I'll just copy this exactly, rename it exercise 3 provision. and then open it, close this, open base code here. So I want to add a provision. I want to add the provisioner to this one. So for us, using provisioner allows you to completely automate modifications to your image. You can use shell scripts, file uploads, and integrations with modern configuration management tools such as Chef or Puppet. To write your first provisioner, you use a provisioner block, and then you can mention the provisioner name inside the first label, and then you have to add your environment variable, and then so the way you want to run, you want to attach your commands. So that's how it works. So let's the block. So now let's add our first provisioner inside the image. Okay, so for that we are going to add exactly below the, so name, here it is, provisioner, where I want to add its build, inside the build. So I have name, and then below the name I have the resources, I have the sources, and exactly below the source here I'm going to add my provisioner. So provisioner, and then label I want to give it shell, and then curly braces, and environment, environment vars, and then a list of items. So it's foo equals, we're defining the variable foo equals to hello world. Then we will attach one more block in this provisioner, that is inline block, and a list of items or arguments. So echo, what do you want to echo it? Adding file to docker container. What is that file? How do you do that? Again, echo backward slash, and then foo is, we have defined that environment variable, that's foo, we have defined that variable. So foo means hello world. So then, so after that I'll say, and after this I want to redirect the output of this variable to the example dot txt. Yes, it's done. So this is the file. I just want to go through that, the piece of module, the provisioner module that I have added one more time. So what it does is, the block, this block defines a shell provisioner which sets an environment variable named foo in the shell execution environment and runs the commands in the inline attribute. So this provisioner will create a file named example.txt that contains the foo is hello world. So now it's time to before we execute it, before we build it, we'll get into our directory, and then we'll open it in git bash. I will do again one more time. It's packer init, and then dot expected comma to the mark at the beginning of next item. Okay, somewhere there is a mistake in this. Which line is that? Invalid multi-line syntax. Okay, I got it. So 26, 27. So at this part there is a mistake. Let me cross check it. Vim cat, and then it is ls cat docker. Okay, got it. So the problem is we here with some indentation and then commas. So I have cleared it off. I have cleaned that. So now let me do packer init. Yes, it's done. There is no issue now. The problem was with the indentation at this line 21, the line number 21, that and then one more issues, I missed this comma. So these are the two issues we have faced there. So then I will do packer format one more time for this. Okay, there is a packer format is required, that formatting has been done. Then I will do packer validate. So the configuration is valid. Fantastic. So now it's time to build our image. For that, I'll clear the screen first. Packer build. So I'll directly say dot. So everything fine. So I hope it should build it with the provisioner. Yes, the same amount of actions are taking place and the same type of actions are taking place as we have seen before with the previous exercise, the exercise number 2, that's building image without provisioner. So now we are building image with provisioner and we'll see. So download complete. So now we are waiting for the pull complete. Once pull is complete, okay, pull is complete, and then the image has been brought and container has been brought, it's been built and it's been killed, and then the build's finished. So the artifacts of successful builds are here. So it's imported docker image is this, and I'm waiting for the container actually. Okay, docker images, you got the two images again. It's Ubuntu. So it's, let's verify the image by running it with a docker. So we have seen that it's running. So now let's try to build, let's try to run the container. So docker run, and then I'll say I, which is interactive. Okay, I'll go with the interactive, but here it's a Windows. Do I need to use T? So without that terminal it's impossible. So because I'm going for the interactive, I'll just say normal one. So docker in detached mode. Then, but if it is in detached mode we cannot see that. That's the, okay, let's run it and see. And this is the image ID that we are going to, because we want to use the base image, it's a supporting image. And then I'll run it here. Let's run the container now. Yes, container has been built. Fantastic. So now let me check docker ps. So there is no container. Docker psa. Yes, the container has been built, and this is what the command it has run, and after that it was dead, it was exited within 0 seconds. So let me get into the docker desktop and see. Okay, two images were built, you can see that. And then let me go to the container. So one container which has been up and then it has been killed. Let me start the container and see what it's going to do. Again it has started and it got exited. Okay, so now this time I'm going to, let me check docker images. You have two images. I'll say docker run again, docker run, but this time it, this is a Linux terminal, but still I'll use it and we'll see. And then I'll run this. copy and then paste it and run it. Okay, we got an error. The input device is not a TTY. If you are using WinTTY, try prefixing the command with the WinPTY. Okay, let's do with prefixing I and then double option WinPTY. Okay, unknown flag docker run help. I just want to bring that. See, we have TTY. This is double option allocate a sudo TTY and u limit. Okay, we do not have another option. That's it. There is nothing. Uh, okay, but still WinPTY it's saying. Let me try one more time and see. Okay, it's Docker error response from daemon. The working directory in PTY is invalid. It needs to be an absolute path. Okay, I have to give the that's Windows terminal actual path I have to give to run it interactive. Anyway, so in there without I don't want to run it interactive because I do not have the terminal because it's a Windows. So now again I will run it in a detached mode and I will see that response at this part. Okay, sorry, not here. In Docker you can see one more container has been built. You can see that I have entered into the layer. So these are the layers that I have mentioned in that command bin bash. It's the image layer and it got exited. So I'll run it one more time and it comes and then it runs and it will die. So that's how we have built it. Okay, so if you want we can docker exec, but for that also we require a terminal, so it's not possible. Okay, anyway the task has been completed with this. So we are able to we were able to use a provisioner and using that we are able to run a container also. So initially we have built an image and then we have attached a provisioner and then we have run some commands, but we are unable to see because of lack of terminal. Because I am doing this in Windows, if I would have done this in if I had done this in Linux, it would have been easier to uh, show that two commands that we have mentioned, that say hello, the foo is hello world, and then the printing it, directing that into the text file. So with this we have done with the exercise 3 also. In the previous exercise we have implemented our first provisioner. However, uh, the packer template that we have used is static. Why it is static? Because we haven't used any variables. So currently if you want to change the contents of the file, you need to manually update your template. So you can use input variables to serve as a parameters for a packer build, allowing aspects of the build to be customized without altering packer template. So in addition, packer variables are useful when you want to reference a specific value throughout your template. So now in this uh, exercise, that's the fourth exercise, we will add a packer variables to parameterize our packer build, making it more robust and more dynamic in spite of going with the static packer template. For that, I'm going to create a one more directory here. The name of the directory I'm going to put is exercise 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 4 and then its variables. So I'll copy the contents of the previous one because that's what we are going to use here, and to that we will add uh, to that we'll add a variable block. So open with code and close this get started and open the our file. So rest all the packer block, source block, build block with the provisioners block. So provisioners block consists of 1 2 3. So two provisioners we have, provisioner 1 and provisioner 2. So all done. So now we want to add one more piece of block, that is variables block. For variable block, let's add a variable to template. Okay, let's add a variable to our packer template. So variable, it should be all provisioners. Okay, yeah, with zero indentation. So here I will add, yeah, this is enough. So variable is our block type, then docker image is our label of the block, and inside that my arguments are type, string type I'm going to take, and then default. So name of the machine, name of the image is Ubuntu and Xenial. I think done. Ubuntu Xenial. So that too with variable we have mentioned. So now it's time to save it. So as the variable has been added to our packer template, that you can see the variable docker image label. Now it's time to do the change in source block also, because so the source block consists of an image which is referenced with the static Ubuntu Xenial. So now you have to remove the static one and you have to add the add a dynamic one which can be referenced to the variable. So for that, first I will add the dynamic one, the one which can be referenced with the variable, and then I'll remove the static one. Okay, so image, then I'll where that represents the variable, that then after that, what's the label that we have added to the variable? It's docker image. Here you can see after you putting dot attribute has automatically come. That's it, this part is done. So now it's time to remove this part completely. Yes, that's it. So the old one has been removed and the new one which is attached with the variable has been attached. So now let me save this, and then just wait, and then let me open the git bash here one more time. Let's do packer init. No problem, absolutely fine. Let me do the packer format. Brilliant, some changes has been made. Then packer validate. Fantastic, the configuration is absolutely valid. Now it's time to do packer build dot. So it's been building as usual. So the layers have been pulled. So once the layer have been pulled, the complete thing has been downloaded. So once it's been downloaded, the complete image, the it's pulling the docker image which is Ubuntu with the Xenial as a tag. So the pull has been completed, and it's been given with this ID. And after that, okay, within 28 second and 714 millisecond, the image has been pulled. But this time What's the difference between the variable one and the normal one? The difference is the output is the same as before, but now the Docker image, you see this docker.ubuntu. Let me click on Docker image, Docker images. If you see, we have two Docker images. The Docker image variable is being used to specify that the Docker Ubuntu. See Ubuntu and then Xenial tag. For this, irrespective of in spite of a static one, we have gone with the variable. So this is the variable and this is the label. This label we have used, and because of that we got the image name here Ubuntu and then a tag Xenial. So because of Docker underscore image variable is being used to specify that the Ubuntu colon Xenial base image should be used. So with this so you have successfully built an image. The build has been finished, so the artifacts of successful builds that you can see on the screen, the message, the artifacts of successful build message that you can see on the screen. So just to cross check, let me open Docker desktop, and we should see, yes, two images. Yeah, Ubuntu and then other image. So images has been created. Now just to kill these images, so what you can do is either you can delete these images from here. So I'll delete from here directly instead of going there and typing the command. It would be easier for the newbies also. For them it would be easier to understand. Okay, so that's it. So in the previous exercise, uh, we used Packer to automatically build an image and provision it from a template. Then we parameterize the template, allowing you to build different images using the same template. So while this is already quite powerful, Packer can create multiple images in parallel. So all configured from a single template. So parallel build is a very useful and important feature of a Packer. For example, Packer can build an Amazon AMI and a VMware virtual machine in parallel provisioned with the same scripts, resulting in near identical images. The AMI can be used for production. The VMware machine can be used for development. Or another example, if you are using Packer to build a software appliances, then you can build the appliance for every supported platform all in parallel and configured from a single template. So in this exercise, we will build a second Docker image in parallel, while the second image is a Docker image for the sake of this exercise. So the second source could just as easily come from another hypervisor or could be a cloud platform. So let's look into the exercise. So we will get to this directory and open one more directory here. It's exercise 5 and it's about um, parallel builds. And let me copy the file from this because that's the latest one, and then place it here. So open this file in VS Code, close this get started and Docker Ubuntu. So let me add one more source. So once you have successfully initialized okay, let's open this, and then before that we will initialize this once, and then we'll go for the uh, git bash, I'll say, packer init dot. Brilliant, no issue at all. Packer fmt dot. Okay, then packer validate dot. So fantastic, no problem at all. Now let me use, so let me add the new resource. Once as we have successfully initialized this template, now I can continue with the rest of the exercise, that adding a parallel builds to that template. So to use parallel builds, create a source. So let me create a source and then add the source to the sources array in the build block. Okay, your sources do not need to be the same type, so this tells packer to build multiple images when the build is run. Let's take an example. uh, when you want to run two images, one is in AWS and other one is in virtual machine, the local virtual machine through VMware. So both can be possible, and you can run from you can create both the images from one packer template. That's the powerful of using parallel builds. But here in this example, we are going to create parallel Docker images. With one script, we are going to create two images. Fantastic. So let's add the resource, let's add the source block to our file, and we'll, so where, yes, it is source, and we should add exactly below the source block. Where is our source block? Here. So we should not replace this source block, we have to add below this. So source, and then again as usual Docker label, and then another label, this time is Ubuntu. It's a different Ubuntu, it's Ubuntu Bionic. And then image is equals to Ubuntu Bionic. I'll go with the Bionic tag. Then commit equals to true. So done, the image has been added, the another resource has been added. So now we have two parallel builds. Build one, that's Docker Ubuntu, that's Ubuntu, just Ubuntu image, and then build two is Ubuntu Bionic. So Ubuntu and then Ubuntu Bionic. But we have to add this, the update, then we have to update our build block to use a new source. This is the source mentioned, but we have to mention this into our build block also. For that, I will come here and I'll type source dot source has been referenced, and in that Docker is one label, and then Ubuntu Bionic is another label, Ubuntu Bionic. Done. Yes, so all set, our file is ready. Now let me get into the and clear the screen and do packer init one more time. Fantastic, no issue. Then packer format one more time. Brilliant. And packer validate. So absolutely no problem. So now let me run, let me build the images, let me build the parallel images, let me run the parallel builds. So packer build. So packer will display the color coded output for both builds. So because we have two builds, for both builds it will, so build has been done, so it has been built. So if you look into this, you can easily tell with build source and output a line is associated with the using either the line color or prefix. So in this example, let's look into that. You have two lines. One is learn packer dot docker dot ubuntu bionic is one, and other one is learn packer dot docker dot ubuntu. So you can make out this at every, see, every you can find the two lines. One is Ubuntu Bionic, other one is Ubuntu. So it's parallelly running. The build has been run parallelly. So both, so one took 9 seconds 103 milliseconds, other took 9 seconds 242 milliseconds. Ubuntu Bionic took 9 seconds 103 milliseconds, and Ubuntu took 9 seconds 242 milliseconds. So here at the end we got two artifacts. Docker one image, this is one Docker image, that is Ubuntu Bionic, and other Docker image, this is Ubuntu. So let me say Docker PS, sorry, Docker images. You can see Ubuntu Bionic and then Ubuntu Xenial. So total we have two. So we have created two. So let's get into Docker. uh, yes, you can see that all. So Ubuntu Xenial and then Ubuntu Bionic, we can clearly see that. Okay, let me clear the all the images. Image one, delete, delete. In spite of deleting from there, I can delete it through the Docker also. Okay, let me get back. So it got open. From the Docker desktop also, I'm directly deleting from the Docker desktop. And then let me get back to this part and say Docker images. So no Docker image. Let me run the build again and we'll see what's going to happen. So packer build and see how much time it will take and how many images it will build. As per our logic, it should build two images. So two images should be built, both for one for Ubuntu, one for the Ubuntu Bionic. So similarly, the example that we have taken, so it is very useful and very powerful tool. The parallel build is very powerful tool. So it's almost come to an end. So Ubuntu Bionic, it took 23 seconds and 67 milliseconds. Okay, it has reached. So it has done. Ubuntu, its Ubuntu is here and Ubuntu Bionic is on top. Ubuntu Bionic took 23 seconds and Ubuntu took 32 seconds, and here we have two build artifacts. So one is Ubuntu Bionic artifact, other one is Ubuntu. So now let me check Docker images. Here it is, you have two artifacts, hence proved. So parallel build is too powerful. It helps us a lot in dealing with the things. So the best case use case for the parallel build is, so the best use case for the parallel build is to run uh, so parallel build is very useful and important feature of Packer. So the best use case is Packer can build an Amazon AMI and a VMware virtual machine in parallel provision with the same scripts, resulting in a near identical images. The AMI can be used for production, and then the VMware machine can be used for the development. It's the best use case. In the last exercise, we have updated our template to build multiple images in parallel. So while provisioners are run against an instance while it is running, post processors run only after Packer saves the instance as an image. So post processors are extremely varied in their function. They can compress your artifact, upload your artifact into a cloud, or create a file that describes the artifact and build. So in this exercise, we will add the Docker tag post processor to add tag to the Docker image. So in a nutshell, a post processor uh, is the block of action that will be done once your image has been built. your image has been built. That's what is our called post processor. It process after the action has been completed. So the best example for that is can be compressing your artifact, or uploading your artifact into a cloud, or creating a file, or just tagging a Docker image, whatever it could be. So to do this, let's get into the directory again, and here I will create a folder. So I'll say exercise 6. It is post processors, and before that let me copy the previous exercise file. So and then open this file in with VS Code. So yes, but before that let me initialize the packer. So for that I will open git bash. So packer init, done, fantastic, no problem at all, superb. Packer, and then validate, all set. It's time to write our first processor, first post processor. So this is the level of indentation I'm gonna take, and our first processor, this is a post processor block type. So I'll take write post processor, and then the label is docker tag, and then space, and then block opens. And what I want to write here is the first argument is a repository. So it's learn packer with learn packer is also fine. Then tags, the tags I'm going to add to this is the first one, it's Ubuntu Cheren is one tag. Sorry, to Ubuntu Xenial we will add a tag as Cheren rocks, and then only argument. So then we will add one more. So here we'll say docker and then Ubuntu. This is our first post processor. Then we will add a second post processor. So label docker tag again, then the same thing comes, we'll just copy paste here, but tags I'm gonna change. So tag, so here I'll put the same tag. Here I say Surya rocks, and here it's Ubuntu Bionic. It's a different one, Ubuntu Bionic. And here also docker.ubuntu hyphen bionic. So rest all are fine, so nothing much to do changes. So we have added the these following post processor blocks inside the build block, but after the provision step, so after the provisioner step we have added the post processors. So these post processor blocks will tag each image with the appropriate tags. Now we are doing parallel build with the post processor. So let's do, and even the post processing is for both blocks. Now the additions that we have to do is we have to add this information in the build block. Let me check the build block now. So build block, we have two resources, source.docker.ubuntu and source.docker.bionic also. So but we want to add so name learn packer shell. So only thing we want to add is the post processor. So provisioner below the s, it's done. So we have added that in the build block. So provisioner, and below that provisioner, and then post processor. So all done, all set. Now let me save this one. Control s and get back into the, so clear the screen and git bash. So now let's build the images, and we'll see the post processor action. So packer build. Okay, before that let's check format also, because we have done some changes. Brilliant, no problem at all. Validate. I hope no issue with this also. So done, no problem. Let's do packer build dot. So now a parallel build. So far what we have done, we have installed the packer, then we have built an image, single image, then we have added the provisioner, then we have added the variable, we have made it that file dynamic, from static to dynamic, then we have run parallel builds. So we have created two images, then we are doing parallel build post processors. So it's a brilliant. We have seen most of the important powerful components and tools of HCL packer. So it's done. So almost it's Docker image done. So we have build finished. The artifacts of successful builds are, so learn one. This is the first. So Ubuntu Bionic and Ubuntu Bionic imported Docker image. Learn packer Surya rocks with tag. That's what I'm saying. The processor, the post processor has come into the action here, and it has tagged the Ubuntu Bionic image with the Surya rocks. Then the second image, the second Docker image has been built, and then the post processor has come into the action, and then this image has been tagged as Charan rocks. Now let us check using Docker command. Docker images. You see? So Charan rocks Ubuntu Xenial, and then Surya rocks Ubuntu Bionic. So this is how you basically tag. This is how you use the post processor to do the actions after completion of the image building. So let us get into the Docker desktop and see. You see Charan rocks and Surya rocks. That's how it will be done. Okay, so let me go back. So if you see, these are the 6 exercises we have done it. So installation, then build and single image, then provisioning using a provisioner, then using variables, and then parallel builds, and then processor, post processor. We have seen most of the powerful tools of HCL to configuration language of Packer. Let's wrap up this Packer module with the CI/CD pipeline of Packer and Terraform. So as we have seen the tools Terraform, Ansible, and Packer. So now let's try to build a pipeline. Of course, we are not demonstrating this pipeline. We are going to discuss theoretically and how does it work. If you would like to explore the pipeline of CI/CD pipeline of Packer, Terraform, and Ansible together, you can do it. I will show you the way to do, so you can do it. Okay, we're going to wrap up this part with this one. Let's jump into this. So it begins with a DevOps guys and Dev plus Ops. I'm saying both. It's not just a developer or an Ops guy. So Dev plus Ops guys, and then they push the code into the either Git or Bitbucket, whichever the one. So either Git or Bitbucket, they commit the code, they push the code, they integrate the code all together. So once the code has been pushed through Git or Bitbucket into the GitHub or another any code repository, any source code manager. So once the code has been pushed, once the code has been stored in that, now it's time for Jenkins to fetch that code. So the Jenkins comes into the picture, and then we will write a Jenkins file, and then the Jenkins file will fetch the code, and then that code will be sent to either one side. The code will be given to the file. If it is a terraform.tf file, the .tf file will be given to the terraform, and if it is a packer file, packer template, HCL, packer HCL template, that will be sent to the packer server. So here we will have a terraform server and then packer server. So for the both the servers, the files, respective files will be sent by the Jenkins. Okay, once it is sent, now so the infrastructure deployment will be done by Terraform. The infrastructure building or creation will be done by the Terraform, and then AMI trigger built will be done by the Jenkins to the Packer. So Packer will build AMI, and then Terraform will build EC2 instance. So now Terraform into action. So it has spin up the instance. We will use a Docker. So it has spin up the instance. Now AWS EC2 instance is ready for you. On other side, you have a Packer. Packer has built an AWS AMI. So now whenever, so as we have made it a pipeline, so now the next process here is, as a DevOps guy or as a developer or ops guy, I have updated few changes in my packer template. You know the packer template, that's HCL packer template. I have added more provisioners, I have added more sources like parallel building, and then I have also added more uh, provisioners and more information, more activities to be done. So those updates, the new updates, new code changes has been pushed and committed to the code repository through Git or Bitbucket. Update it is done, then Jenkins again triggers the build AMI through the packer. So now it's going to build a new updated, upgraded AMI. So this upgraded AMI will be pushed into the Terraform, and then this Terraform will take this AMI, and then it will spin up the new instance. So this is how you can continuously build build your EC2 instances through the changes that you have given to the Packer template HCL. I hope it's clear, or else I would just uh, summarize the whole pipeline. So you make a changes to your HCL template. You have added a new provisioner, some new activities to your template. Then it will be pushed to the code repository through Git or Bitbucket. Then Jenkins comes into the action once the code has been pushed into the pushed or committed into the code repository. Automatically the Jenkins triggers the build pipeline. So the pipeline, the pipeline has been built, so it will trigger a build AMI to the packer. So the packer comes into the action, and then it will build an AMI image with the new changes, and then the updated new image AWS AMI can be seen here. So now this image will be taken by the Terraform, and then Terraform get this new updated AMI, and then it will set up, or it will spin up the new instance. This is how it works. So now let us And one more thing, for the configuration, it's going to use either Ansible or a shell uh, or chef. Basically, I'm when I said provisioner, I just mentioned about the shell only, but you can use either of the tool, Ansible or chef. So any tool you can add, even Puppet. This one is the fourth one is the Puppet. So anyone you can add. So if for in the same example, so next time you want to add more features, you want to add more configuration features to your AWS AMI image. For that, now initially you have only shell provisioner. So now you want to add a chef provisioner. So then DevOps guy added the chef provisioner. Then he pushed the code, committed the code. Jenkins got triggered the build pipeline. Then Jenkins trigger build AMI. Then Packer comes into the action. Then Packer has built a new image with the uh, chef provisioner activities. And once that is done, so it got updated with the new image. Now the Terraform takes this new image and spins the new instance. This is the continuous pipeline. A continuous integration is there at this part, and continuous deployment is there. So deployment is taking place here. So this is how a CI/CD pipeline can be built with a Packer and Terraform using Jenkins automation tool. So now let me show the documentation one. So let me this, yeah, here you can see build immutable infrastructure with a Packer and CI/CD. Let's look into the overview. So this actually, I'm just going through this guide so that if anybody wants to do if anybody wants to create a CI/CD pipeline with Packer, so this is where you can find the information. So this guide focuses on the following workflow for building immutable infrastructure. So this workflow can be manual or automated, and it can be implemented with a variety of technologies. So the goal of this guide is to show how the workflow can be fully automated using the Packer for building images from a continuous integration or continuous deployment pipeline. So first we can do any of three. So build images using Packer in CI/CD, or upload the new images to S3. So once the image has been built, you can upload that to S3 bucket. Either one is CI/CD. So let me go to this build images using Packer in CI/CD. This is what we have seen. So this guide consists of these two examples. One is how to build immutable infrastructure with Packer and Circle CI workflows. Other one is Packer and Ansible to build immutable infrastructure in CodeShip. Let me click on this, and I'll just quickly go through this so that you will have a clear idea. This is written by the Bear. He's a senior staff security operations in Circle CI block. So it's an actual official website of circleca.com. So instead of using Jenkins automation, you can use a Circle CA. So here is the complete flow how to do. You can find the files also. Yes. So this is how you can build your CI/CD pipeline with Circle CA also. However, I have taken the example of Jenkins automation tool, not CI/CD, not Circle CA. Anyway, so this is how we build our CI/CD pipeline with Packer and Terraform and automation tool such as Jenkins or Circle CI or anything else. So let's wrap up the Packer. So we have begun with looking at the pain points with the existing tools, and then we have seen the benefits of Packer and what is Packer, and then we have seen some of the use cases of the Packer. Then we have seen the Packer terminology such as artifacts, builds, builders, commands, data sources, post processors, provisioners, and templates. And after that, we have looked into the Packer command CLI. We have done the first exercise, that is installation of Packer CLI into the Linux machine, that is Ubuntu. Then we have demonstrated various Packer commands such as Packer init, Packer build, Packer console, Packer inspect, Packer fix, Packer validate, Packer FMT. So this kind of commands, sub commands we have demonstrated, and after that we have moved into the packer templates. So the initial packer template that we have seen is packer template using JSON format. So we have completely gone into the in depth of the JSON. So the builder section we have seen, then the provisioner section we have seen, then user variable section we have seen. After that we have seen a theoretical complete procedure to build an Azure image with the package. Then we have entered into the demonstration of creating Azure AWS Amazon Web Services AMI image using JSON and JSON template and packer. So that's what we have did it. So we have created an uh, Azure Amazon machine image using packer. So then we have entered into packer templates using HCL format. Then we have moved into HCL format. We have seen the basics of HCL format, and we have seen the documentation of the HCL format. Then we have started our exercise. Our first exercise is to install the packer in Windows machine. Then our second exercise is to build our first image. Then our third exercise is to uh, add a provisioner to that. Then the fourth exercise is using variables. Then we have run the parallel builds, and finally we have closed that with post processors like tagging an image. I hope you enjoyed this packer session, not only packer, terraform, ansible, packer. So if you enjoyed it, you just please kindly spread this videos to everybody so that everybody can get benefit out of it. You just because I'm putting a lot of my resources and efforts to just give this all knowledge just for free of cost. I'm not expecting anything other than just a love from you. Thank you, and keep watching, keep loving, keep liking, keep subscribing it, and keep spreading. See you again in another module, the fifth module of this intuitive DevOps for you course.